We have a customer in steel, in concrete, for building or other equipment, can be water tower, it can concert houses with cinema library. You can do pillars inclinated, like you can see. Pedestrian bridge in steel, here it's in Paris, done by Ancora. Classic bridge, well, not so classic, but and you have all the language and all the regulation in the interface. So another pedestrian bridge with cables. Underground, same you can do on Chinese language if you want. Some timber. Here it's a wood in France, in Annecy. The rooftop, well, there is a famous, I would say, concert. I would say, yeah. So of course we are linked with 2D DXF and DBG. So here it's a mining industry, and they have done this 2D DXF, and you can import multiple 2D DXF, and after you can use them as background, create grids. I would say do, even if we are BIM ready, I hope so, we can do, I would say, classical methodology if needed, depending on the input. So here it's more, I would say, the 2D DWG are not designed by you, not by the structural engineer. If the 2D DWG are really designed by the structural engineer, you can import it. Here it's a French electricity tower. So this was designed in AutoCAD. And when you import, you can say, okay, all this line will become this profile. And of course, it will be set, but it works only if the DWG, 3D DWG are really good, I would say. Of course, Revit is our central, I would say, kernel of all the inferring. From Revit, you can go to robot, but to a lot of other software. With robot, you can link with Inventor, and in robot, you can do volumic analysis with, well, not only Inventor because it's SAT file, so you can come from other software, like you can see. We are linked with Inventor with frame generator. I mean, if you create a frame in Inventor, you will get it directly in robot. Of course, we are linked with Advanced Steel, and you can import, export the element, and update. Synchronizing means that if you change profile in robot or in Advanced Steel, you are not obliged to create it all again. It will change only the profile, the material. You see, well, of course, we are linked with Revit, and there is a global need. Revit don't do all. After, if you do need really a detailed steel design, you need Advanced Steel. Of course, for all concrete, you will do it in Revit, including the rebar, and it's linked to robot. Of course, like every Autodesk product, it's open in API. It means that you can code, you can create a small Excel. Here, one of our customers do always this kind of thing, so he creates something who creates the element, and after you can load back the result. If you don't want to do some post-treatment in Excel, no problem, you can do what you want. Like Revit and Civil 3D, in robot you have Dynamo, so you can create the structure, put result back, like you can see. So in terms of analysis, you have linear, non-linear, with order with P delta, which is useful for cables, and when you have this kind of smooth structure, I would say. We can do elastoplastic analysis. And we have model analysis. So you will choose basis. After you will have spectrum analysis. And here you will be able to load a text file. For example, if you want, I don't know, in nuclear or something, sometimes they have their own spectrum. You can directly load them. Of course, we are linked to Eurocode 8. And because I have a slide dedicated for that, we have NTC 2018 in it. So after you can use it. And you have some result based on this. So the result. You can have a lateral seismic forces methodology. Well, I don't know if a lot of customers do, but in concrete, we used to do that to have a general order. So it's in. We can do a pushover analysis. So you will define the plastic hinge, and after you will find the, I would say, performance point to validate the comportment coefficient. So you will put the plastic hinge nearly everywhere. After you will have a load, local load. So you will find, so at first, of course, it's linear. After you can see there is the first plastic hinge who breaks, not breaks, but are used in nonlinear, I would say. And after you stop the analysis at some time, because at some point we never go until this way. And you load, according to Eurocode 8 or US regulation, the, I would say, legal spectrum. And after you find the point where it should work. For example, if you have something which is dynamic, like in mining industry, when you want to break rocks, there is a lot of vibration. So we have harmonic analysis inside, and we have the same harmonic analysis, but on a spectrum. It means from, because, for example, when it's in place, there is always the same frequency, but when you start or when you stop this kind of equipment, you can have different range, so you can do the same analysis but on a range of frequency. Foot flow analysis according to US, and well, for European, usually we use only footfall analysis on a frequency response function. You can do general buckling, which is very useful for your code tree, and you can do it in nonlinear if it's quite sensitive. For example, we have a customer, Altrad, who does all the, I would say, formwork and scaffolding for example, the Eiffel Tower or for church. And sometimes they need to do in nonlinear because it's so huge that they're not sure it's accurate to do it in linear. And after you can do nonlinear and linear time history analysis. So for example, for pressure on a column or something like that, just you can do nonlinear, it means in the solicitation, but the material itself stay linear. Okay. After we have a CFD wind generator inside robot. Okay, so if it's classic, you will use Eurocode 1 generator of wind and snow. But if it's something not in the classic mode, you can use it, or you can use both. And after, as engineer, choose the best for your project. For your code tree, you will be able to do global imperfection and local imperfection. And after, you can do both based on the general buckling deformation. So it means that because here, this is the first mode of deformation. And if you have not a so easy case, well, here I create something easy to see that it's fit. But you can do the mode analysis and set, okay, I want this because of my number of column or this to 2.3 centimeters. And it will create the local imperfection and the global one. So as you have already seen in customer sample, we have a shell, we have beam finite element, and we have volumic. In volumic, we have hexahedron and tetrahedron. We have a cable in finite element. So, well, I don't know if you do cable, but we have two ways. So first, you say what will be the tension at the end of the analysis. And the other one is globally, you say, I have 10 my cable of 2 centimeters, and after you find the solution for you. So we can do shell or volumic. We have a new method since 3 years, which is a load takedown method, which is nicely used in concrete in, I would say, in France, but elsewhere too. It means that there is no finite element. robot will do, I would say, like we used to do manually. It will do, for example, this rupture line, put this load on this beam, and after, so you have the load on this beam. After we do a 2D file of only this beam, we find the result at this node, and then we analyze this beam, and then this one, and we do it level by level. Because sometimes with global finite element, it gives something which will be true for creep, but because we build level by level, sometimes there is something which is not so accurate. So there is this two methodology in robot for years. It's useful in US too because they do two kind of analysis. And after you can have directly, for example, you see from which level the load come. So it's really, as you understand, I like this analysis. After you can do phases. So step-by-step analysis. So first you have this, then you have this, then you have this, then you put the cable, and then you remove, here there was support, as you can see. You remove the support. You can do this in robot. So there is no limit in number of beams and nodes. I would say the computer would do it. Usually our customer do 40,000 nodes, for example, Ancora, with big hotel in Monaco and Nice. I think it's the bigger I've seen. For beams, I would say the best, it's a French stadium from Ancora, but there was not so many nodes because it's beam compared to finite element, I would say. When it's concrete, our customer do many finite. So as I already said, there is all the language and pretend language inside. You don't need to install other add-ons. And when you, when here you select regional settings, by default, it will choose for you the local database of section and the local database of regulation. It means if I choose Italia, it will set the software for Eurocode 3 plus Italia national annexes, all this stuff, and profile we used to have in Italia. And after you can switch. For example, if you want to work in Italian language, but with US regulation, of course, you can. And the best is to choose, for example, US globally, and then just change the interface. So all will be in Italian, and you can change after if you want to print out the calculation note in US or well, in English language, I would say. So you can create, there is all the classic section, I would say, but if you have your own section, you can add him, and you can set for multiple materials. I mean, this can be steel, here it can be concrete, and of course with Hugh module, we will be able to do the global analysis. So as you already see, we do steel, reinforced concrete, timber, and some geotechnical for foundation. And we have the load generation according wind and snow and seismic. So here it's the, I would say, global printout of all the regulation. Same in concrete here. In wood, mainly Eurocode and US, and in geotechnical, same mainly Eurocode, US and Canada. Well, we used to have Russia, and I would say Eurocode plus local annexes or all regulation. Yeah, we have Russian too because it was really used for gas and petroleum project, I would say. Wind and snow. So here you have the wind and snow according to local regulation, I would say. You will see after. So CFD is not linked to any code, it's a global. And here, after you have all seismic codes, and as you can see, if we don't have, you can import a text file, define all the elements. So in Eurocode, we have 0, 1, 2, 3, 5, 7, and 8. Okay. In Eurocode 4, you can define a mix section. We will do the FEM analysis on it. So you will have bending moments, sharing, but we are not linked to a database of altri or something like that, so we don't do post-treatment of Eurocode 4. And in masonry, you can do the beam the way you want, but we don't have post-treatment according to Eurocode 6. So here you have the regulation, so you can, I would say, choose it. If, for example, one of our customers in France, French Electricity, takes the Eurocode but change something on it, you can edit the text file and change a little bit the regulation, save to a new French Electricity Eurocode 0 to be sure. So here it's a wind and snow regulation. So here you will select you will draw this. After you will launch this interface. So you will put the level according to the sea, where there is wind, the level, and the permeability. You will be able to choose if you create all, I would say, the portal frame, because the pressure are not the same on every element, or only one. And after, we do the classic, I would say, CPE minus CPI to find all the pressure. And after, you have the pressure on the portal frame like this. Well, here it's one. Usually it creates about, I would say, 12 elements. For Eurocode 2, we have reinforced concrete beam. So you will be able to define it, the sharing, where there is opening, and after it produces this kind of shadowing directly. And then you will be able to send it back to robot. We have the same for column, okay, with general buckling and local analysis. And reinforced concrete wall, where you will be able to analyze with ductility low, medium, and high ductility. So to this to be performed, of course, you don't need to have only one wall. You need to have the global 3D in. And after you export, it will do the shift like we do for beam, but for wall, I would say. Here, you can analyze a slab, okay? We have Eurocode 2 post-treatment, so you will have the bending moment, and then you will have the openings and the reinforcement needed in two directions, okay? And if you have, for example, a column or loads, there is a pushing post-treatment according to Eurocode 2, sorry. And if it's more, I would say, civil works, you can define the beam and ask to have the section of, I would say, rebar without sending to robot beam or etc. Okay, and you have the same for column. And after you will need to set the cover, all this, the quality of concrete, if it's the same as defined in the global material, which is logical, but sometimes if after you see it's not correct, you can increase the value for post-treatment before launching it again everywhere. After you have a node verification in robot. And of course, there is a link, as you already know, with robot. So directly up, and then you will be able to send back the rebar. And for shell, or I would say general regulation, you will be able to send the result in well, the bending moment if you want, or directly the need of reinforcement. Okay. And by the way, for example, you can send all in robot, or like I've done here, I don't want to send all because I want to analyze only my slab. So I select only my slab and the support. And here I don't have this global file, by the way. I have only my slab with the support to avoid, I would say, a global deformation of the soil, which not makes sense for my slab, in my opinion, I would say. Same, we have Eurocode 3 in steel, where you have all post-treatment of Eurocode 3. So class section, type of load, lateral buckling, and some parameter to find the buckling diagram. And you have interaction coefficient, and you can do the fire calculation according to, I would say, different loads in Eurocode 2. And after you can add protection if you want, and it will you will have the temperature inside the steel, and so the fact if it works or not with temperature. We do thin section 2, like you can see, and you have this post-treatment according to Eurocode 3. And after we do connection according to Eurocode. And when you have done this analysis, after you will be able to find the real rigidity and set back in the file. Well, this is all the connection we do. You can define new in wood. So in timber, we can do buckling, lateral buckling. In fact, like in Eurocode 3. The difference, if of course there is KDF and KMOD, I would say, coefficient to do the Eurocode 5 for wood. So of course we do it. And well, you can do camber consideration in Eurocode 3, and you can do it, of course, in Eurocode 5 too. And same, you have fire analysis, and you can add protection or not at the surface and define the material who protect it. Okay. Well, we do classic beam, but after we'll do this section of beam, you know. And after there is a load classification, if it's long-term, mid-term, or short-term, to this KDF and KMOD before. After we do reinforced concrete footing according to Eurocode 2 and Eurocode 7. Well, in compression, we do 2, but in general stuff with 2 bending moments, like you can see here, we do it. And after this 3D reinforcement, you can change it, etc. And then it can be printed in PDF or DXF if you want, or send back to Revit for the rebar. To know a little bit better about, there is a YouTube channel done by our support where they explain good tips and tricks level by level, I would say. So we have troubleshooting with meshing, steel design, reinforced concrete for beams, reinforced concrete for more